por el camino del desierto, el viento me despeina, suave aroma de colita, no nada, nada de labios.
Number two, we want to find the characteristic polynomials of a and b. So to find the characteristic polynomial, what we can do is we can look at a minus lambda I and take the determinant of that and set that equal to 0 and multiply everything out. But for 2 by 2 matrices, we can use the following formula. The characteristic polynomial, which we'll just call P A of lambda, is going to equal lambda squared minus the trace of A times lambda plus the determinant of A. So the trace of A is just the sum of the diagonal entries. So in this case, that is going to be negative 2 minus 5. And the determinant of A we can just find by multiplying negative 2 and negative 5, adding that to 0 times 3. That's lambda squared plus 7 lambda plus 10. So that is the characteristic polynomial of A. For B, we can do the same thing. PB of lambda is going to be lambda squared minus the trace of B plus or times lambda plus the determinant of B. It's going to be lambda squared minus 12 minus 9 lambda plus negative 9 times 12 minus negative 7 times 14. It's going to be lambda squared minus 3 lambda minus 10. So that's the characteristic polynomial of B. For number 3, we want to find the eigenvalues of A, B, and C. So A is the matrix 2, 3, 0, 4. So we could find the eigenvalues by finding the characteristic polynomial and solving that quadratic equation. Or we can notice that this is called an upper triangular matrix. That means all the entries above the diagonal or below the diagonal are 0. So for upper triangular matrices, the eigenvalues are the diagonal entries. So that means that lambda is going to equal 2 and negative 4. Similarly, for lower triangular matrices, those are matrices which have 0 above their diagonal, so the eigenvalues are the diagonal entries. So in this case, our eigenvalues are negative 1, and 5. And for C, we have the following 4 by 4 matrix. And it turns out this is a diagonal matrix. So that means that all the entries above and below, I'll use a different color. All the entries above and below the diagonal are 0. So that means for diagonal matrices, the diagonal entries are the eigenvalues. So eigenvalues are 2, 3, negative 4, and 1.